In this video, we will learn about segments and how to find their areas. First, what are segments? Let's look at the circle to get a better idea. O marks the center of the circle. Points A and B make a chord, while points A, C, and B form an arc. This part of the circle bounded by the chord AB and the arc ACB is a segment. This arc ACB is a minor arc, so this is a minor segment. This part of the circle is also a segment. It is bounded by the chord AB and the major arc ADB, so this is a major segment. Now we know what segments are, but how can we find the areas? Let's look at this minor segment again. You can see that the segment is part of the sector, and so the area of the minor segment ACB is the difference between the area of the minor sector ACBO and that of the triangle AOB. If the area of the minor sector is 25 square centimeters and that of the triangle AOB is 10 square centimeters, the area of the minor segment ACB is 15 square centimeters. However, often the areas of the sector and triangle are not given. Just like this example. Instead, the radii of the circle and the angle subtended at the center of the circle by the arc PRQ are given. How then can we find the area of this minor segment PRQ? Remember that the area of the minor segment PRQ is the difference between the area of the minor sector OPRQ and that of the triangle POQ. So we need to find the areas of the minor sector OPRQ and the triangle POQ. Remember that we can find the area of a sector using theta divided by 360 degrees multiplied by pi r squared. And we can find the area of a triangle using half r squared multiplied by sine theta. Since we know that the subtended angle is 120 degrees and the radius of the circle is 7 centimeters, and taking pi to be 3.142, we can find the area of the minor segment, which is 30.1 square centimeters. What if we want to find the area of the major segment PDQ? Can you see that the major segment PDQ is made up of the sector OPDQ and the triangle POQ? This means that the area of the major segment PDQ is the sum of the areas of the sector OPDQ and the triangle POQ. If we know or can find the areas of the sector and triangle, we can find the area of this major segment. To find the area of the sector OPDQ, we use the angle subtended at O by the sector, that is, 240 degrees. To find the area of the triangle POQ, we use the angle subtended at O by the chord PQ, that is, 120 degrees. With the areas of the sector and triangle, and taking pi to be 3.142, we can use them to find the area of the major segment, which is 124 square centimeters. Finally, did you notice that the major and minor segments together form the circle? So alternatively, if we know the area of the minor segment, we can quickly find the area of the major segment by taking the difference between the area of the circle and that of the minor segment. First, we know the radius of the circle is 7 centimeters. So the area of the circle is pi times the radius, or 7 squared. Next, we also know the area of the minor segment PRQ is 30.1 square centimeters. Hence, if we use the area of the circle to minus that of the minor segment, and taking pi to be 3.142, it will give us the area of the major segment, which also gives us 124 square centimeters.